In this video, I'm going to show you how you can implement polling of a web service in make.com. When building workflows that trigger jobs on other software platforms, it's usually best practice to rely on webhooks so that that software platform can just let you know when the job is done. Not all software platforms support this though, and at times you need to implement some sort of polling mechanism. If you don't know what polling is, it's the equivalent of waiting for a delivery to your door, yet you don't have a doorbell and the delivery guy can't knock on the door. So you need to check the front door every 5 minutes to see is the package there. That's polling. A webhook is the equivalent of a doorbell. So the delivery guy just rings the doorbell to say the package has arrived. But clearly the webhook / doorbell version is a much better design. But as I said, it's not always available. In a recent video, I built a make.com automation to interact with a platform called browser use. This system allows an AI to control your browser, similar to OpenAI's operator. A difficulty I had in this build is that when you trigger the browser use platform via API, there's no way to pass a webhook to get the response when it's finished. And depending on the complexity of the task that you pass this platform, it could finish it in 1 minute, or it could take 20 minutes to finish it. So without being able to register a webhook with browser use to inform us that the job is finished, we need to put in some sort of polling mechanism to check when the job has been completed so that we can then continue on processing with the results from the job. So you've probably seen a lot of these types of workflows online, where you might have one call to trigger the job or trigger the task in whatever service it is you're integrating with. Then you have a sleep or a wait, which can wait up to 5 minutes. So there it's set to 60 seconds, but you can set that to 300 seconds. And then you'll have another module to essentially fetch the completed task. And then from there, you can carry on with the workflows and add in whatever other modules you want using the results from this module. So number one, the sleep module in make.com is limited to 5 minutes. It can't go past that. And the second thing is, this is a one and done style workflow. So once it flows through here, it can't go backwards. So if it hits this module and the status of the task is still processing, it can't go back and wait for another 5 minutes and try it again, not with this design anyway. So we need a polling mechanism to actually achieve this. Within make.com, on any of the paid plans, the maximum scenario execution time is 40 minutes. So within a polling style setup, you could potentially run it for 40 minutes waiting for the job to finish. An alternative approach would be to split this scenario into two. You have the first scenario which triggers the task or triggers the job, and then it saves it to Airtable or Google Sheets or some sort of database to say a task with this task ID has been created and it's still pending. And then you would have a second scenario which would then, on a schedule, maybe every 15 minutes, which would look to see in Airtable any open tasks or open jobs, and then it would trigger this module to fetch the result, and if it has been successfully completed, it can update the status in Airtable. That's not a bad approach, but it'll consume a lot of operations because you would need to run that on a schedule, every 15 minutes, every day. So that's going to chew through a lot of operations. So having a polling mechanism is ideal in scenarios where the task can take, let's say, longer than 5 minutes, but it should be completed within that 30 to 40 minute time frame. And that's what we're going to do today. If you'd like to level up your make.com skills, then check out the link in the description to our community, the AI Automators, where we have a number of courses, including our make.com masterclass. We have a wide array of system templates and micro templates built on make.com and on N8N. We also run regular workshops to provide support to members on getting their automations, whatever they are, up and running. Check out the link in the description. We'd love to see you there. So what I've done is I've created this dummy web service in N8N. It has two endpoints. The first one is just to trigger a task. It does nothing other than to just say task successfully submitted. So in reality, this will trigger a job within a software system. And then the second endpoint is the fetch task status. And this is kind of to simulate, has the task been completed or is it still in progress? And what this endpoint does, so it just sets up a count, which is initially set to 0. And then it's a simple condition to check, is that counter less than 5? And if it is, it goes up this track, it increments the counter by 1, and it just returns the webhook as it's still in progress. And then when that counter has been incremented to the number 5, it goes down this track. It then just resets the counter so that I can test it again, and it returns as complete with the status of finished, and then it provides some sort of dummy output like the AI generated image is here, and it provides a link. So again, this is just a dummy kind of web service setup to simulate polling. N8N has native polling, as you can see here, by the fact that you can pull this track back around into another node. So I'll just simulate this by clicking test workflow. And what we've done is we're triggering the task. In other words, we're just hitting this endpoint, which then comes back as task successfully submitted. And then we're going into this kind of polling loop. We're waiting 3 seconds, checking to see is the job finished. And if it is finished, we can do something, as you can see there. And if it's not finished, we go back to wait for another 3 seconds and check again. And if it's still not ready, we go back, wait another 3 seconds and check again. And that will continue on within N8N until the workflow times out. So that's how a polling mechanism works. Within make.com, we don't have the ability to loop a track back to another node. Instead, we need to use a router and a repeater. But the way we do that then, let's break this apart. So if we trigger this scenario now, and you can see it has run and it's responded with task successfully submitted. So the dummy triggering of the task is now working. So then we need to use a router. We'll bring up here. And then within this upper track, what we need to do is use a repeater. So a repeater is kind of like an iterator, except that you're hard coding the number of cycles or the number of loops that it's going to run through. So we can put this in at, let's say, 10 repeats. But at a very basic level, what we need to do is just drag this down. Okay, let's change that to 5 times. Now what it's going to do is it's going to hit this service 5 times. So if we just run it, so it's triggered the task and then it's gone into this loop and it's hit this 5 times, as you can see. So you can see status is processing there with no output. The second one it has finished, but because I'm resetting the counter in my dummy web service, it's probably just going to be processing again. So there's a few changes we need to make now. So when the status equals finished, we can stop polling, we can stop checking because we can move on with the workflow. And that's what this second track down here is. This is where we're going to move on with the workflow and do other things. And we need to set a variable based off that status. We'll use set multiple variables, and I'll explain why in a second. And then we'll add an item. So we're going to have this as polling complete, and we could set this to true. So it'll only go down and set polling complete to true if the status equals, and then you need to check what it was. So I believe it's finished, isn't it? So you can see there, status equals finished. So when that filter is true, task complete, then it'll go and it'll set the data. That's the other thing, is the data we also need to set. It's not just the control mechanism for the polling, which is what we've done here. We also need to say, okay, this can be the data and this is the output. Okay, so we now are setting the data here. The problem is if we run this again, it'll still run 5 times, but it's only triggering this once. So we now need to put in a filter here to say if polling complete is false, then continue to check the status of the task. Now the problem here is we don't actually have polling complete as a variable to check. So we need to add another module, which is get variable. And with get variable, you're only using the name. So it's polling complete, because that's what we said a minute ago. And then you can put that in there. If polling complete is equal to false. Now, not equal to false because it hasn't been set. So maybe if polling complete does not exist, maybe that's what we're looking for. And then we'll set this to in progress question mark. So now let's run it and see. So we have fetched the task 4 times now. So the first 3 times it was processing. And then on the 4th time, it got the data, status finished, and we're getting the output. The generated image is at that URL. We're then setting that data here. Polling complete is true, generated image can be accessed there, and off we go. Now, the other thing is this happened instantly. We actually do need to wait. So then maybe here, let's add a module, which is wait or sleep. Then you can put in a delay that works for the service that you're integrating with. So with browser use, it could take 20 or 30 minutes to actually respond. So it probably makes sense to have a delay of 2 or 3 minutes in between fetches, because it could take quite a long time. Whereas if you were integrating with a service that usually responds within 30 or 40 seconds, you could put in a delay of 10 seconds, let's say. So for the moment, I'll put it in as 3, but I think you just need to suit that for whatever service you're integrating with. So maybe we just need to increase this repeats to 10. So let's do that. I click run once. So we've got this polling complete variable 10 times, and it's either been false or true. The times that it's false, it's gone down this track, and it's only gone down here once. It's waited 3 seconds. It fetched the result, and as you can see, the status was finished. It then set the data, and then the next time it checked it, it was then true. So you can see the first time it was empty, it didn't exist, and then the second time it was true. Now the reason that responded straight away is just the way I have this dummy web service set up. So if I actually run this again, it'll run it a few times because this dummy web service is just waiting for this counter to equal 5. So that's what you can see there. So the loop again has run 10 times, but it's actually checked it 6 times, and only on the 6th time did it actually return the result. But then let's say you wanted to continue on the workflow with the result from that task. So maybe it's a case if you wanted to go to an LLM, let's say GPT-4o Mini, and you're asking it to explain the results of the task, and then you need to pass those results into the LLM. So I've created those system prompts here. The problem is I can't access the output from this top stream of the router. In other words, I can't access the output from the completed task, as you can see there. And that's the thing about make.com. So if you have modules running here, they're completely invisible to modules running here. So the only way that you can pass data in between these rows or these streams within a make.com workflow is by using these set variables and get variables that you see there. Now you could also persist it in a data store or a Google Sheet or an Airtable or something, but this is the easier way to do it. So if we bring this over here, we need to add another module, and this is again get variable, but now we need to get multiple variables because we also need to pull the output from this task that I've saved here. Okay, so we'll rename this get data, and let's get both variables. So polling complete and data. Okay, let's save that. For the moment, let's just unlink this, and I'll show you why in a second. So if we run this again, so we could make an assumption that polling is complete and just go straight to the LLM, but it's probably better practice to actually just make sure of that. So we've fetched polling complete there. So if polling complete is equal to true, then it can continue on into the LLM. The reason I'm putting that there is on the off chance, let's say this browser use platform takes 2 hours to complete a task, then this polling mechanism is going to fail. It'll run it 10 times and it'll still be in progress 10 times. So it'll never actually output the data. So that's why it does make sense to actually put in a filter, which is job done, question mark. And if polling complete is true, it means the job is done. And you can then go to the LLM with the results from the service. Here's the task results. And now you're able to see the data that has come through. And that can be then passed into ChatGPT to analyze and carry on with the workflow. So whatever your workflow is, maybe you're uploading an image, maybe you're saving to a CRM, whatever you're doing, you can do it then on this track. And this track can then build out much further, knowing that you have the correct output from this service. So that's the best way to do polling in Make.com. It's not ideal. You are burning through a lot of operations because even though in this example, the task was completed on the 6th occasion, as you can see there, number 6, this repeater still had to go through whatever iterations were left. If I have this repeating 10 times, this finished on the 6th time, but you can see we have 10 here because it had to check to see was polling complete. So it doesn't really stop it. And that's where it really does burn operations. And then the fact that you can't share data in between streams within a router means you need to use these get variables and set variables, which again is just burning operations. And obviously operations cost money. You don't have this issue with N8N for a number of reasons. Number one, you're not paying per operation. And number two, the way it loops around like this, once this condition is met, once it's finished, it'll just keep progressing. So the N8N polling solution is a lot cleaner, but this definitely works. I've used it on a number of different projects and templates that we have up in our community as well. Let me know in the comments below if you have any other polling ideas on how you can handle situations like this. Thanks for watching, and I'll see you in the next one.